Okay, here we go. How does that say number 8? Is that even true? Oh, it is number 8. It's just we put it on the back. Did we just do that like that? I guess we did. Okay. This is page 2 of your review, and apparently number 8. We're very special. Okay, so it says graph each of the following log graphs. So front page was exponentials. Now we're talking about logs. Identifying at least 3 points. So there's 4 spots in this box because one of them is going to be your what do you call that thing? Oh, asymptote. And then the other 3 are going to be the points. And so that is our plan, Stan. Okay, and so we want our argument in this case, our base is 3. Right there, you see that cute little 3. And so we want to get a 0, we want to get a 1, we want to get a 3, and we want to get a 1 over 3. So we take this little argument, little guy right here, that argument, and we want x minus 2 to equal 0. We want x minus 2 to equal 1. We want x minus 2 to equal 3. And we want x minus 2 to equal 1/3. Okay, that's what we want. So up here, we want x to equal 2. Here, we want x to equal 3. If I add 2 over, that gives me 3. If I add 2 over, that gives me 5. And if I add 2 over, that gives me 2 plus 1/3. So that's the asymptote plus a little. I want you to think of it that way, the asymptote plus a little. Oh my God, the hot tea is so good. Okay, so then now what does that give me for f of x? Now I'd like to do all of this math out, but there's not a ton of space. So I'll do it on this one and I'll do it on the natural log graph. And then on the other ones, you're gonna have to catch on. Okay, so if I put a little, let's see, go log base 3, this is super small writing. Can you see that? If I zoom in, then you can't see the whole thing, so it's a real dilemma. All right, that's log base 3 of, if I put the 2 in, 2 minus 2, that would give me 0 plus 1. That's the best I can do. This log base 3 of 0, I'm going to circle it because that's what I'm looking at first. That is undefined, and then undefined plus 1 is still undefined, turns out. Okay, so now I'm going to do log base 3, and I'm going to put 3 in for x, and it's going to be 3 minus 2 is 1 plus 1. So again, I'm going to look at this part first. I'm going to evaluate that. Log base 3 of 1, that's a 0. Plus 1 is 1. Okay, now I'm going to do a 5er. So I've got log base 3, and if I put a 5 in for x, 5 minus 2 is 3 plus 1. This right here is a 1, and then plus that 1 equals 2. And then finally, this one's the one where it's just a big payoff. You're going to love this, watch. I'm going to go x, which is 2 plus 1/3 minus 2. Plus 1, except for you can't really see that. Sorry. It's not awesome. So that 2 and that negative 2 go away, and you get log base 3 of 1/3 plus 1. What is this? That is a negative 1. Negative 1 plus 1 is 0. Okay. Woo! We just nailed that. So we've got, if I had a little highlighter here, which I do not, of course, I would highlight my answers. Okay, so my vertical asymptote, on the exponential graph, you're looking right here at the k value for the asymptote. Not so with the log graph. With the log graph, you're looking in here at the argument, which is why you see how a 2 would make this a 0. Guess what? That's what's undefined. So this is x for vertical. So vertical is equal to 2 is my vertical asymptote. 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Okay, and so this is x equals 2. Okay, and then now I'm going to graph the 3 and the 1. So over 3 up 1. Then I'm going to graph, ooh, not that 3. I'm graphing in the x's and the y's here. So I'm going to go 5, 2. 1, 2, 3, 4, 5. 1, 2. And now I'm going to go back over here where it's the asymptote plus a little. So the asymptote plus a little, 0. Something like that. Okay, there's my log graph. Woo! Domain. If I put my finger on the x-axis and I ask myself, is graph happening? No. Yes. So that was 2 to infinity. And I put my finger down here. Is graph happening? Yes, all the time. So that would be all reals. Is this sucker increasing? Every step over that I take to the right, is it going up or down? It's going up, so it's increasing. Okay. It's increasing over 2 to infinity. Okay. Alrighty, here we go. Part B. I'm not going to show every single step like I did on the last one. If you need to watch the last one, part A, again, to really try to understand this part or this part, you can, but I'm going to try and speed it up just a little bit. So 4 is my base, so I want 0, 1, 4, and 1/4. That's 0, 1, b, and 1 over b. And then here, my argument is just x, because this plus 2 is not in parentheses with it. Okay, so this is just going to be x. Well, that wasn't too exciting. Okay. All right, but so now I've got to figure out what that means when I put it in. So negative log base 4 of 0 plus 2. So first thing I have to do is evaluate that. And then I'm going to apply the negative. In this case, though, that's undefined, so this whole sucker is undefined. But it's going to get more exciting right now. So just wait for it. Log base 4 of 1 plus 2. Again, I'm going to do the evaluating of that. That is a 0. Negative 0 is still 0 plus 2 equals 2. Boy, that was exciting. The trick on this one is to make sure that you apply that negative after you have figured out how to evaluate this part. Log base 4 of 4 plus 2. So this right here is a big old fatty what? I don't know. 1? Oh, yeah. So negative 1 plus 2 is 1. Log base 4 of 1/4. This is, oh, so fun right here. Look at that. That's a negative 1. Negative 1 plus 2. That's a positive 1 plus 2 is 3. Alrighty, then. Let's do this. So I'm dealing with 4s, so and 2s. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay. Sorry, that was exhausting. I had to take a break. Okay, something like that. Don't care about that side. So this says undefined at 0. So remember, when it's on the axis and it's hard to see, I want you to go a little bit beyond the arrows so that I can see that you actually had an asymptote there. And then now I'm going to go 1, 2. 1, 2. This graph has been shifted up 2, so what was normally here is now plus 2. 1, oh, I just did that one too. How about 4, 1? 1, 2, 3. Oh, that is 4. 1, 2, 3, 4 is up 1. So this is going like that. So now this is our asymptote plus a little. 0 plus a little. And then now it says go up to 3. So why is this thing flipped upside down? She asks. Why is this thing flipped upside down? The answer, my friends, is because of this negative out front. Oh, this negative out front. So this shifts the whole graph up too, but then this flips the sucker down. Okay, 2 more of these. Man, this is a lot. You better feel the love. After this, I get to go grade your ESQs. Yay! Okay. All right, so here we go. Ooh, natural log, tricky business. Okay, so this is a natural log graph is what we're trying to do. Okay, and so it's going to be 0, 1, b, but our b value is our base, and our base is natural, or I'm sorry, this is a natural log, so our base is e. So that's our base, and then 1 over our base is 1 over e. Okay, now this one has an argument, and so I suggest, especially with the natural log, I suggest you do this little tricky trick here, where you actually put the argument in and say what you want it to equal. It's going to take out some of the thinking. So it's x plus 1, we want it to equal 1, which means x must equal 0. Here we want x plus 1 to equal e, which means we need x to equal e minus 1. And then we want x plus 1 to equal 1 over e. So we want x to equal 1 over e minus 1. Sorry that writing's so small. I'd like to zoom in for you, but then you won't be able to see the graph. So these are hard choices I have to make. Sorry. Oh, does anybody want to see my thing? I know I showed it to you today, but some people are really grossed out, so I thought I'd put that in there right now. That's for you, Rohan. Who else was my other one got skeeved out? Well, ooh, that was from another class. Here, you can look again. Oh, you thought I was done, didn't you? Nope. Okay. Stitches are coming out tomorrow. There you go. Okay. Alrighty. Who else got skeeved out today? Somebody else did. Oh my gosh, who was it? I can't remember. Was it Evelyn? Nah, I don't know. Okay. All right, so -1 in there. So if I do a -1 in there, that is going to give me a 0, which is undefined, friends. If I put a 0 in for x, then this one's going to be natural log of 1. So that is e to the what equals 1. That's a 0. Remember, e is my base here. So when you see me do that motion, e to the what equals 1, that's e to what exponent equals 1, and the exponent is 0. Now this one's where this is pretty slick. So what am I thinking? Oh, I'm going to put in an x right here. So the natural log of e minus 1, that's my x value, plus 1. But look, those little ones cancel, and I'm left with the natural log of e, which is 1. That's base e to the first equals e. E to the what equals e, it's a 1. Okay, and then finally, this one is awesome possum. That's my x value, 1 over e minus 1, and then plus 1. Those guys cancel again, and I get the natural log of 1 over e. E to the what equals 1 over e, that's a -1. Okay, those are no joke. That's pretty hard to do. The other thing that's kind of tricky here is you have to know what e minus 1 is. You can use your calculator for that. That's going to be about 1.7. Uh-oh, my thing just said it was running out of batteries, and I'm wondering if it recorded what I just said. We don't know. I'm just going to go with it. What I just said was we don't know what e minus 1 is. You can use your calculator. That's going to be about 2.7 minus 1, which is 1.7. And then 1 over e, again, I think is about 0.4, I think, minus 1. So you can do that on your calculator, but that's going to be about a -0.6. Okay. I'll tell you how to deal with that when you get there too, where you don't even have to go get your calculator if you're using that good brain you've got on your shoulders. Okay, hopefully my phone doesn't die. That's right, it's not charged. I know that's shocking. Okay, so -1 is undefined, so that is my asymptote. These are vertical asymptotes. So it is x equals -1. And then I've got 0, 0, nice. And then I've got e minus 1, which we just said is 2.7 minus 1, which is 1.7 is going to be a 1. So 1.7, is that right? Did I just do that right? 1.7, yep, 1.7 is going to be up at 1. So about like that. And then now I've got 1 over e minus, so we decided this is like -0.6. The other way to think about this is, here's your asymptote. It's saying -1 plus a little. So -1 plus a little is going to be like right in here, and that's supposed to be at -1. So I didn't have to go get a calculator if I'm thinking about this as my asymptote and this being a little bit more than it. So that's my asymptote plus a little, and then -1. So that's a way to avoid calculator. Not that we don't love our calculator, but I'm just too lazy to go get one. Okay, domain. No, 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 no. Yes, 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 yes. So from negative, ooh, Stephanie, darn it. I don't have my white out, I should. That's a -1, and then to infinity. That's a -1 to infinity. And then my range is all reals. -infinity to infinity. And then this sucker, every step I take going to the right, it's going up. So this is increasing. Oh, I just realized I didn't answer any of those questions on the last problem. Shoddy work. So shoddy. Okay, then let's do it right now. We'll pretend like that didn't happen. My asymptote is going to be x equals 0. Sorry about that. Which I did put in here. I just didn't write it up here. My domain. No, no, no. Yes, 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 yes. So from 0 to infinity, my, this is going to keep going across and going down. It will eventually cross the y-axis or the x-axis, and it will go down. So believe it or not, all these values down here are being hit. It's just hard to see it right there. There's no asymptote here, so this is going to keep going down over time. So my range is actually negative infinity to infinity. And then is this sucker going, as you read from left to right, is it going up or is it going down? It is going down. It is decreasing. It is decreasing over the interval from 0 to infinity. Okay. And then finally, sorry, I goofed that last one up, or letter B. Everybody say a quick prayer that my phone doesn't die in the next few minutes. Okay. Here we go. Let's see. We're almost done with the hard part because the graphs are the parts that sucks. The other stuff goes pretty quickly. I think I should be able to get through it pretty fast. All right, what's my base? It's a 2. So that means I want a 0, a 1, a 2, and a 1/2. And x is, this is my argument. So I want negative x to equal 0, which means x has to equal 0. Negative x to equal 1, which means x equals negative 1. I want negative x to equal 2, which means x equals negative 2. And I want negative x to equal 1/2, which means x equals negative 1/2. Okay, my asymptote is at 0. And now I'm going to take these x values and substitute them in. Log base 2 of 0 plus 1 is undefined, friends. Log base 2 of, if I put in a negative 1. Okay, so that's positive. So this is log base 2 of 1 plus 1. This is a 0 plus 1 is 1. Yikes, that was a lot. Log base 2 of negative 2 plus 1. This is log base 2 of 2 plus 1. Log base 2 of 2 is 1 plus 1 equals 2. Good Lord, that was hard. Log base 2 of negative 1/2. I'm going to hope that you understand that that's minus a negative, which is positive 1/2, plus 1. This right here is a negative 1 plus 1, which makes this sucker 0. Okay, so let's see here. 1, 2, 3. I'm going with bigger spacing because the numbers appear to be smaller. And that way I have a little bit of space to deal with some stuff. Okay, my asymptote is x equals 0. Again, please go beyond the arrow so I can see. 0 is undefined. Okay, negative 1 and 1. Negative 1 and 1. Negative 2 and 2. Negative 2 is up 2. So I think this is doing this sort of thing. And that makes sense because that negative x reflects it across the y-axis, correct? So what would have been here is now being reflected across. So what does this say? This says take your asymptote and go to the left 1/2. It's saying, I always say it's a little bit to the side of the asymptote. In this case, it's a little bit, instead of to the right, it's a little bit to the left. So it's going to be negative 1/2 is here, and that is a 0. So here is what the graph looks like. Okay, nailed it. Negative infinity to 0, and then negative infinity to infinity. And as I take steps to the left or to the right, this sucker is going down for real. Okay, on that happy note, after 18, almost 19 minutes, that's page 2. Peace out.